Okay, back to our datasets of SDG data. We've seen now a method, the CRISP method, how to approach a problem. And we have done an introduction on data science. For every data scientist, it's important to have some kind of hacking skills. Hacking skills is the art to manipulate data in a very rapid way. And for this, we use Python. As a starting point, I downloaded some data sets for you. For each indicator from 1 to 16, all data sets are from our World in Data. So credits to our World in Data. You can do this as well just by right-click on the individual indicator and download the CSV. This is just for your convenience that we can start to explore some data sets with programming or with hacking skills. Within the tool landscape for data scientists, of course, there are many different tools you should learn, or you have to learn to manipulate data. You have to learn many different tools, and one tool is, of course, Excel to manipulate some data sets. So I opened now indicator 8.11, and if you see here, if you browse through it, if you zoom in, the file is provided in comma separated file, CSV. For Excel, you would have to convert it into individual columns to really see what is in this data set. Here you can see already, my God, I'm here on a German laptop, and it's already crushing the data set itself because number representations are not constant across the globe, and this poses always a problem for different countries. Typically, you should operate on the US or English style Excel in the back end, then this does not happen. And this is also the reason why I mostly hack not with Excel, because Excel, it's also very difficult to control. Mostly I do this with Python. So I cannot teach all different kinds of Python hacking. This is more about tips and tricks and the classical tools, and to enable you for a quick start. When speaking about Python or rapid prototyping, or when you want to hack, I think there's no way around Anaconda. Once you have installed Anaconda, you will open up a so-called Anaconda Navigator, and you get really many different tools where you can start to program, from simple techniques like a notebook explorer, which we will use in this lecture, towards really professional programming tools like PyCharm, which I can highly recommend to use this kind of tool from JetBrains, which is an excellent editor for programming. In this lecture, we will use the Jupyter Notebook itself. You can start a kernel. Within this Jupyter Notebooks, you can see here my Vorlesung, that means lectures. I have Value Chain Analytics lecture, I have SDG lecture, so I can go into the notebooks. I highly recommend that you always split up the notebooks towards the data sets. The clean data sets I've shown a couple of minutes ago are already located in the data OVD clean indicators. All data sets will be provided in GitHub for you. Let's start with doing the first visualization. Again, it is not, the lecture is not to present everything step by step. It should give you a quick start into the topics. The Jupyter Notebooks itself can be done for each cell. You can do even a markup language or a code. You should always take care that you're doing a lot of documentation next to it. And we are using, for the first time series visualization, we are using two major libraries, which you should be aware of. It's the so-called Pandas library and the Plotly library. Okay, what is this Pandas library all about? I've provided here the link. So what is Pandas doing overall? And if you're coming from the Excel world, and I expect that most of the people are coming from the Excel world, Pandas is more or less doing the same things what Excel is doing in the spreadsheet programs. And you will find many different concepts of Excel also mirrored in Pandas. And this is the reason why Pandas is really so strong and used everywhere whenever you work with tabular data. And this is what we did already. And these are the data sets which we downloaded, which are tabular data. So if you go into the documentation, you see immediately that there's a wonderful documentation on it, how to start and how to import this library. So you start always with import pandas SPD. You should always use the same namings behind. The data structures in Pandas and in Excel, in Excels you always have this kind of worksheets. In Pandas it's called data frames. In Excel a column is a series in Pandas, a row heading is a so-called index in Pandas, a row is a row, and the empty cell is displayed as a none. And this kind of handling a data frame is a core of how to start with Pandas, and also I think a very wonderful starting point for the programming itself. A second library which I can highly recommend is Plotly. Pandas itself is more focusing how to handle the data, and Plotly is a pure visualization library where you can do wonderful plots. And when looking through the different examples of the plots, you can see we have here basic examples for a line chart. And if you would do, for example, this command here, you import Plotly and then you're doing the line chart, you will see how simple it is. Pandas itself is coming as well with a plotting library, but it's not precisely designed for plotting. So I recommend really to go with a Pandas data frame and with a different plotting library, and I prefer Plotly over different other libraries.